Today we are going to be starting our third section within Chapter 4, all about word problems related to ratios. So applying everything we've practiced so far in Chapter 4, Sections 4.1 and 4.2, applying that now looking at word problems here. So our goal is that you guys are going to be able to solve real-world problems involving ratios. We don't have any new vocab, so continue to review the vocabulary words. Those are in the class notes folder on Schoology, so that when we have conversations in class as well as directions given to you on any kind of assignments, you're understanding what is being asked of you. All right, we're going to dive right into Learn 1, in which it's all focusing on being able to draw models to solve word problems involving ratios. We should be familiar with using bar models, maybe from elementary school. And in these types of word problems, using bar models in a visual is going to be really helpful for us in identifying what information is given to us and then what we're going to be solving for. So let's use problem 1 as our first example. Problem 1 tells us that Megan prepares a fruit punch using apple juice and orange juice in the ratio of 4:3. So if the total volume of the fruit punch is 630 milliliters, let's highlight that as important information. The total is 630 milliliters. Our job is to find what the volume is of just the apple juice. Okay, so we're given a total and a part. So this is an example of a part to whole problem. So to help us in solving and using our bar models is I want to set up my picture to represent my ratio of 4:3. My apple juice and my orange juice. Okay, apple juice is 4, so I'm going to show a picture of 4 units. And the orange juice is 3. So I'm going to draw a picture showing a visual of 3 units to compare there. The apple juice to orange juice is 4 units to 3 units. Tells us that the total volume is 630. So that means this total amount is going to be 630 milliliters. What we're trying to find is just how much the apple juice is going to be. So I can see here that between the apple juice and the orange juice, that makes up 1, 2, 3, 4, 5, 6, 7 units. So my 7 units is equal to 630 milliliters. Well, it might be helpful for us to figure out how much 1 unit is so that I can find 4 units of just apple juice. So from here, what I'm going to do is I want this 7 units to turn into just 1 unit. So I'm going to divide by 7. And if I'm doing that to one side, I need to do it to the other side as well. So 1 unit, if I take 630 divided by 7, that equals 90 milliliters. So in my picture, every box is going to be 90. When finding the volume of just the apple juice, I'm going to take 90 times 1, 2, 3, 4, and that equals 360 milliliters. So the apple juice has a volume of 360 milliliters. So that is how we solve a part to whole word problem, where we're given the total, we want to find a part. Let's look at question B. If Megan, we're going to use the same model here, or the same ratio of 3:4. If Megan uses 520 milliliters of apple juice, we want to find out how much orange juice she's using. So we have a part to another part. So this is an example now of a part-to-part problem. My ratio is still the same as far as my picture goes, with 4 units and 3 units. But now in part B, this is telling me that just the apple juice is equal to 520. We want to figure out what the orange juice is equal to. So we can go through and follow some of the similar steps we did up here using just what we know about our apple juice. So I can see for the apple juice there are 4 units equal to 520 milliliters. So that's going to look like this. 4 units equals 520 milliliters. I want to figure out what 1 unit's going to be so that I can find my orange juice, just like we did up here. So I'm going to divide by 4 on both sides to get 1 unit equal to 130 milliliters. So every box is equal to 130. To find my orange juice, I have 3 units of it, so I'm going to take 3 times 130 to get a total of 390 milliliters. Looking at problem 2, a box contains baseball and football cards. The number of baseball cards to the number of football cards is 5 to 1. Let's start by drawing our picture. Baseball to football is 5 to 1. In part A, if the total number of cards is 1,380, find the number of each type of card. This is a relationship, a part to whole relationship, because I know my total and I'm finding for just one, or for the parts, each type of card. So this whole thing equals 1,380 cards. I have a total of 6 units. I'm going to divide by 6 so I can get my amount for just 1 unit. When I divide, I get 230 cards, so each box is worth 230. My question is to find the number of each type of card. So for baseball, I have 5 groups of 230. When I multiply that, 5 times 230, I get 1,150 cards. And for football, I just have 1 unit. So for football, that's going to equal 230 cards. I don't have to do any multiplication there. As a way to check our work, if we were to add this amount plus this amount, it should total to the original cards that we started with, 1,380. Let's keep going. Moving on to Learn 2. We're going to continue to draw models to solve problems, but now instead of 2 numbers in our ratio, we're going to be looking at ratios that have 3 numbers. So problem 3, the number of coins collected by Abby, David, and Brian is in the ratio of 2 to 5 to 8. We also know that David collected 85 coins. So in part A, we want to find the number of coins Abby and Brian each collected. Let's start by drawing our picture for Abby, David, and Brian. So Abby has 2 units. David has 5 units. And Brian has 8. We also know that David's is equal to 85 coins. So this picture is equal to 85 coins. This is a part. If we know David's total and also his units, we can use that information to help us find Abby's and Brian's. So for David, he has 1, 2, 3, 4, 5 units that equal 85 coins. I want to know just for one box, so I'm going to divide by 5 on both sides. So 1 unit equals 17 coins. So every single box in my picture is going to be worth 17 coins. For Abby, we take 17 times 2. There's 2 groups of 17, so she has a total of 34 coins. And Brian has 8 groups of 17, which when we multiply that, we get 136 coins. So we have now found the number of coins for each of them. In part B, now our job is to find the coins collected by all 3 kids or to find our total. So we need to add 34 plus 85 plus 136 to get 255 coins. And moving on to the last problem. A piece of ribbon was cut into 3 pieces, A, B, and C. The lengths of the pieces are in the ratio of 5 to 2 to 3. Let's draw our picture there. Let's just start with that information, then we'll read again. So for A to B to C, they're in the ratio of 5 units for A, 2 units for B, and 3 units for C. So we have our picture. We also know that if the length of the ribbon before it was cut, so before everything was broken up, this is really telling us our total was equal to 120 inches. We want to know then how many inches each piece is after it's cut. So this all together equals 120 inches. I'm going to set my total number of units equal to my number of inches so that I can find the amount for just one box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units equals 120 inches. If I divide by 10 on both sides, 1 unit is going to be equal to 12 inches. So each box is worth 12. But now I can figure out how long each piece is. So for A, I have 5 groups of 12, which equals 60 inches. For B, I have 2 groups of 12, which is 24 inches. And for C, I have 3 groups of 12, which is 36 inches. And I found each of my pieces that way. So the overall idea here with solving these types of problems, first we want to draw a picture to represent our ratios. Then we're going to figure out, do we just have a part? Do we have a total? What are we solving for? Setting that equal to each other, finding one unit, and from there we can find any other amount that the problem might be asking of us. Come ready to class with questions. If you have them, make sure that you have this all filled out. You can go back and rewatch anything if needed, and I will see you in class.